Thank you, everyone. Thank you. Yeah, so my name is Jonas Rentele. I work at Fujitsu as a solution architect, as Rainy said. And yes, we have 2 vouchers for Fujitsu Forum. It's an event that we do in Germany every year. It's the largest IT event in Europe. And last year, I think it was 14,000 people who was attending. And the voucher includes the entry to the event. It includes the air flights from here down to Munich and the hotel rooms, right? So it's everything that you need to go. Right? As long as you get an okay from your boss, of course. Good. So Fujitsu, who are we and what do we do? Well, we're a small Japanese company, 160,000 people worldwide. We do business in over 100 countries in the world. We have over 150 data centers worldwide. And yeah, we do a lot of different stuff. I work in the product division, right? So selling products, but we also do managed information services and cloud business and all of these sort of things as well as a company. Anybody using any Fujitsu equipment in here? Good. A few of them? Okay, good. Did anybody watch TV last night? Yes? If you were watching Roov, you were looking at a stream that came out of a Fujitsu storage box. Because the playout system at Roov is a Fujitsu box. So actually, if you watch TV, you are using Fujitsu technology, right? And also, if you are browsing internet, you're most likely also using Fujitsu equipment. Because we do undersea data cables. And we are the market leaders. We have about 85–90% market share when it comes to cables under the sea. So more than likely, I can't say for sure that the line here to Iceland is a Fujitsu cable, because I don't know, but more than likely it is, right? And we do everything, as we say. We do supercomputers, we do prepackaged solutions. We're going to be talking about that today, or Michael is going to be talking about that, the PrimeFlex solutions. We also have a really large 8 sockets PrimeQuest service, as we call them, for large databases, for example. We have traditional storage, the one that we're using at Roov, for example, the eternal storage, which is my speciality, to say. We'd also do, laptops, desktops, etc. And a customer there is, am I allowed to say this, Rainy, or not? Yes? City of Reykjavik is using our desktops, right? Yes, so basically we do a lot of different stuff. So whatever your needs are within IT, I'm more than sure that we can accommodate you. So with that, I'm going to hand over to Michael and our specialist on Microsoft and Fujitsu. So welcome, Michael.
There we go. Just a matter of minutes. Okay, there. Well, good morning, everyone. And warm welcome from me as well. My name is Dominique, and it's a great pleasure to be here. Last time I was in Iceland was about 10 years ago. And I think many things have changed in the meantime. So it's very exciting to be back and be in this very, very unique country. Now today I'm here to talk to you about something else that is quite unique, something that's only happened very recently, which is the launch of Windows Server 2016 and everything that comes with it. Before we start though with what Windows Server 2016 and Fujitsu do together, I'd just like to give you a little brief generic overview over the server itself. Because in fact, what many people don't realize when you buy a Windows Server license, that there are a lot of features and functionalities built in, and many people don't actually use them, which is a bit of a shame because you've paid for it. It's there. You just need to enable it or switch it on or just leverage it, right? So basically, simply, there are 3 editions that are relevant. There's an Essentials edition, a Standard edition, a Data Center edition. You might have heard that things have changed versus the 2012 edition. And one of the more important things that has changed is that the data center edition now has indeed new functions and features built in that are not available in the standard edition or the essentials edition. So the things I'll be talking about today actually only apply to the data center edition. That being said, it's probably the edition that you would be using anyways, since it still has the unlimited virtualization rights. You can still run as many Windows instances on a data center licensed server as you wish. Standard edition still only allows you to run 2. If you need to run more virtual machines or more instances than just 2, you get more data standard licenses. So that's kind of still the same as it was in 2012. In 2016, that is being enhanced with some additional storage, networking, and security features. Okay, so today we're going to focus mainly on the additional storage features, though, because it's probably the most interesting. So let's just move on and give, I'd like to give you a very brief overview over the, let's say, 5 main use cases or scenarios that we tend to see with Server 2016. So the virtualization and containers, disaster recovery, clustering, storage, and hybrid cloud technology. Let's start with virtualization and containers. You know that Hyper-V has been around for a long time. That's nothing really new, but now a new technology has been introduced called containers. You may or may not have heard of containers. It's basically a cloud-driven technology. Now, it allows you to run applications, microservices, also in a kind of a protected environment, like a kind of a sandbox, but they're very, very, very tiny. So a container, if you can take a look at these here, containers don't have their own operating system image like virtual machines do. Containers can share a common operating system image. And that means you have one operating system image, one copy, one storage instance, but you can run 10, 20, 300, 3,000 containers with just one version of the operating system. So it's very, very cost effective. Starting up containers happens very quickly within a second or 2. And because of that, containers are suitable for these microservice cloud applications for the future. Today, there are not many containerized apps available yet. You actually need to produce apps that will work in containers, but that's going to happen over the next couple of months and years, most certainly. If you live in Linux land or open source land, cloud land already, then you're probably familiar with containers, and now this has come to Windows as well. That being said, Hyper-V is still around, so you can still, of course, run very, very traditional virtual machines. They're still there, except that Hyper-V has been expanded and updated and has been upgraded so that virtual machines now can scale up to 12 terabytes of RAM and up to 240 cores inside a virtual machine. So with that kind of performance and that kind of scalability, there is no application you cannot virtualize. You can virtualize any database, you can virtualize any application. In fact, you can virtualize other hypervisors. Hyper-V will let you run Hyper-V on top of Hyper-V, which is maybe weird at first, but that would allow you to provide a private Hyper-V space to tenants within your network or within your organization. So that means your tenants can find their own personal private Hyper-V space on top of the Hyper-V that you might run or maintain or own. And that's why this has become so big. These are new enhancements, and there's a couple of new features in there, like PCI slot mapping, which simply means you can now use you can map a PCI card, any kind of hardware that runs in Windows Server can now be accessed within the virtual machine. That can be something as exotic as a 20 milliamp serial port adapter. It could be USB cards. It could be whatever you like. Production checkpoints are possible now. Well, actually, they were possible previously as well, but now they're officially supported. So when you take a snapshot of a virtual machine, that will go inside the virtual machine and actually make the application consistent. You can snapshot and restore and back up applications using nothing but Hyper-V right out of the box. Another interesting new technology feature is part of disaster recovery has been added. And what is especially important about that is the native Azure integration possibilities. So any kind of on-premises Windows Server 2016 can be very, very easily connected, of course, to Microsoft's Azure cloud. And that can give you, for example, off-premises failover capability. If you want to have ultra-high availability, but you don't have a second data center available, many people don't, right, because of cost or whatever, you can kind of replicate into Azure, and if something goes wrong on your production servers, you can even fail over into the Azure cloud and keep working and stay online. So that is a native technology which is built in now. And another technology is called storage replica. And this lets you do that on your premises or within your own network, and you don't need any kind of cloud services. So storage replica will actually let you mirror and replicate storage or data from one Windows 2016 server to another, and the only thing you need is a TCP/IP connection, nothing else. You don't need any special storage hardware or any licenses or anything else. When you buy Windows Server 2016 Data Center, it's built in, you just need to switch it on. So any piece of server hardware with Server 2016 on it is already capable of synchronous or asynchronous mirroring, depending on, say, the distances. If you've got long distances between locations, you would mirror asynchronously. But if you're just on premises from one building to the next, you can do it synchronously as well, and you get transparent failover. So if one building, like building number 5, crashes or blows up, or let's hope not, but what if it does? All applications will immediately start up on the other site. You'll have no data loss and guaranteed data integrity at all times. So the only thing you need is 2 servers, a couple of hard drives, and you're done. That's all you'll have to have. The clustering feature is still an integral part of everything that Windows Server does, and in fact, it's the basic foundation, for example, for storage replica. It's the basic foundation for these Azure failover services. It's a basic foundation for many other storage services as well. And you might remember storage, Windows clustering from back in the day, you know, Windows 2000, 2003, but it's come a very long way. So the new clustering feature in 2016 has been massively improved. It's a lot more robust. It's easier to use. And one of the interesting things that has happened is you can actually, I don't know if you can see on this picture, there are various different Windows editions running here. We've got a 2012 R2, a 2012 R1, if you will, and a 2016. And they all work together in the same cluster. So what you can build now is hybrid clusters where certain nodes will run 2012 R2, others can then run 2016, and that'll work in a mixed environment. And the reason you might want to do this is you might have an existing 2012 R2 cluster, and you might want to upgrade it to 2016. One of the reasons you might want to upgrade to 2016 is because of that storage replica. Because that will then let you replicate your files onto another location not for free, essentially. You still have to upgrade to 2016 server licenses, but it's a lot cheaper than buying new hardware. So keep your hardware, keep it in place. I might be making everyone's life miserable now here. I mean, he might want to sell some servers, and so does Fujitsu. But the fact is, you could keep your servers, and instead of buying all these new servers, just keep them the way they are. Put Server 2016 on top. And usually, any kind of server from a brand name vendor, say, well, Fujitsu, Hewlett-Packard, or any of the others, any of these servers you bought within the last, let's say, 2 or 3 years should be Server 2016 certified and ready. So just put 2016 on, upgrade that, and you get all these new functionalities built in, and then extend the life cycle of your environment. Stretched clustering is I was just mentioning that transparent failover capability from one building, for example, to another building site. That stretched clustering is basically the functionality underlying that storage replica and that transparent failover. So it will let you build one cluster that has various nodes and even storage in different locations. And that will let you then build these totally redundant, mirrored data centers, literally the holy grail of IT, but using nothing else than a bunch of servers and a bunch of hard drives and nothing on top of that. Now, storage, of course, there's one of the most important and interesting features in Server 2016. The hype feature, literally, is being storage spaces direct. Now that has been all over the place for years and years and years. In fact, Storage Spaces Direct was first released with the Server 2016 preview back in 2014. So today we're in 2017, and that means this technology has actually already had about 2.5 years to evolve, to develop, and to perfect itself, or to get perfected. So you don't need to wait for, say, a new version of Server 2016 R2 or Service Pack. It's not going to happen. Server 2016 has already been through its beta testing phase for the last 2.5 years. There are over 1.3 million Windows insiders, they're called, all over the world. These are voluntary beta testers that have already provided over 17 million items of feedback that works, that doesn't work. Microsoft's fixed most of that, believe it or not. So all of this is proven technology. It's been around for over 2 years. It's not brand new. It's only been released to the general public in October last year. So, well, it might seem new to you. In fact, the technology's been around for a long time. The good news is these storage spaces direct need nothing but standard servers also and a bunch of hard drives inside. And because it's built into Windows, there is no cost. The only thing you need to do is, well, enable it. It's very, very simple to do. And a couple of, figures on the side there. Deployment time in 15 minutes. In fact, it's less than that. If you actually see an engineer set up storage spaces direct, it's probably something more like just one single PowerShell command, and then it happens. It's really that's all there is to do it. Then you've got your performance. I've got some real-life performance numbers. This, of course, marketing slides, so I have some real-life numbers for you in a minute. Fault tolerance, efficiency, and all that. I'll mention these in a little more detail coming up. So how does this work? What you need, some standard servers. This is a 3-node configuration. Later we'll see you can start with 2 nodes, though. You don't need to have 3 or 4. You can begin with 2. And you only need Ethernet. So you get 10 gig Ethernet. This is the minimum network environment, but I'm guessing most of you probably have 10 gig already. Servers are connected to 10 gig Ethernet, and you'll need some flash storage devices in each server. And the first step is you build a cluster. When that cluster is built, then you do that PowerShell magic. You issue the create storage spaces command, and that creates a storage pool. It's just a bunch of terabytes. Some terabytes being fast because they're flash-based, other terabytes are low-cost because they might be based on SATA hard drives. So you get the best combination, right? And on that pool then, you can define your volumes, which are like drives, essentially, and on that, you can, for example, then deploy your virtual machines, and voila, you get a hyper-converged stack. And the only thing you need is 3 servers, some Ethernet, some Windows, and a bunch of disks. Done. There is nothing else you would need. Anything on top of that just adds cost and adds complexity, and is probably not adding any features or functions either. At this time today, Windows Storage Spaces Direct will scale up to 16 nodes per cluster, and you can do 416 drives, and lots of memory in there. There's lots of storage in there, rather not, well, memory too. If you've got 16 servers and you can scale each server hundreds and hundreds of gigs, you can see how big these clusters can easily get. But remember that a cluster can also be just 2 nodes, and that'll give you a very low-cost entry point as well. You scale by adding servers, usually. So if you run out of space or run out of compute, just get another server, plug it into the network, you join it to the cluster by the way you would usually add a node to a Windows cluster, and everything else beyond that happens automatically. The hard drives are detected, they're found, they are claimed by storage space, they're merged with the pool, all the volumes automatically extend, and voila, you get more storage. It's very, very, very simple and very easy. Adding a cluster node to a storage space cluster usually takes less than an hour, and you've got more capacity. So that 2-node option is available. You can start with 2 nodes, and the beauty of a 2-node setup is if for some reason you do not have a 10 gig Ethernet environment because it's a branch office, for example, or just a small location with 3 or 4 employees working there, then 10 gig Ethernet might be too expensive. So in that case, you can just use direct cable, copper cable to connect the servers with each other, and thereby saving a whole lot of money. And you can uplink to the customer network on 1 gig Ethernet, or to your client network, whatever you want to call it. So it's a very low-cost way to get started. Add 2 more nodes, and you get a 4-node cluster. Now, 4 nodes is the minimum configuration to get that stretched scenario where you can put these nodes in 2 different locations and then have synchronous mirroring going on, right? The only thing you'll have to watch out for between these 2 locations is like minimum bandwidth and latency requirements, but that will depend on your setup, and I'm sure when the time comes, your favorite partner will help you to determine whether you're ready to go or not. So let me just give you a brief explanation and kind of an animation of how this works. One of the key things when Microsoft designed Storage Spaces Direct was to be as safe and as reliable as possible. So one of the key things, of course, is drive fault tolerance, and you probably know that from your old RAID arrays, right? So a hard drive fails, and that you're still online. And this works basically the same way. So Storage Spaces Direct can keep up to 2 additional copies of data. So you get your original plus a copy plus another copy, which will give you 3. This is a mirroring setup, right? So it's 2 copies, but it does support parity, and it even supports a dual parity option. So something like erasure coding. Others might call it RAID 5 or RAID 6. Okay, but the safest option would be mirroring, and I guess it becomes clear that even if a disk fails, you've got enough copies of data, and storage spaces will automatically rebuild data on any hard drive that still is left over or has capacity left. So you can come along, you can replace that failed drive at any time you need to, no risk, no challenge, and no hurries. The same will work, by the way, if a server fails, because again, here, storage spaces will always distribute data in such a way that there are never 2 copies on one server. So in this case, even there, when a server fails, as you can see, you still have enough data copies left over to stay and remain online, and then you can fix that server whenever you need, or whenever the time permits, or whenever the spare parts arrive. Once that's happened, then of course the rebuild commences and everything's back to normal. So it's very, very simple and very easy to do. Another thing that's important to note is that fault domain awareness. Even if you have different racks, or what's not seen in this picture, if you're in 2 different rooms, you can tell storage spaces that certain servers have a certain location, and based on that location, data will always be distributed in such a way so that even if an entire rack goes down, or a room crashes, or there's a power failure, you will still remain online. So Storage Spaces is aware of all kinds of different locations like racks and chassis and nodes, and even the site, which would be the physical room or the building, right? Okay, and just a little bit of background of how this actually works, because the way the storage spaces operate, I mentioned that hybrid storage pool, right, where some terabytes are flash-based and very fast, others are very low cost. This could be a setup where you're using some flash and maybe some SATA hard drives. Now, SATA hard drives are not exactly the fastest, we all know that, but they don't need to be. So in a storage space, the flash devices are always used as a cache. So all the read-write requests that the server makes will always go on to these flash disks. And that's why they are so important. And the performance will be very, very good. As soon as data starts to cool off, storage spaces will destage that onto the mechanical drives, the spinning disks, that are, of course, a lot less expensive, but also a lot slower. The good news is, as data moves through these hard drives, you can see there is a hot and a cold area on this capacity tier, and Windows storage spaces will actually keep some hard disks in a mirroring configuration and others in a parity configuration. Parity being RAID 5. And you're probably aware that RAID 5 can be a very, very low cost. You get lots of terabytes, but it's not very fast, it's not very safe. Whereas mirroring, of course, is very fast and quite safe, but expensive. So what you're seeing here is actually a combination of both. You get the speed of flash and mirroring combined with the low cost of parity all at the same time. And you don't need to know how this actually works, neither do your applications or your users. All of this happens in real time while the system is running. And there is actually, in fact, there is really nothing you can configure or optimize, and you don't need to. Again, I'll show you some performance numbers later. This could be another slightly more extensive setup where you're using some NVMEs, which are even faster flash devices. NVMEs being, again, about a factor 100 times faster than SSD even. So you can use those as a cache, then use SSDs as the hot space for mirroring, and then mechanical drives for your very low-cost storage tier. And again, Windows will handle all of this transparently, automatically in the background. You don't need to optimize it or set it up or make it work or even change it or tune it. It's totally self-optimizing. Now, I'd like to do a little bit of myth-busting because there's a lot of rumors out there that I keep hearing, and I'd like to address a couple of these. I guess the first one is many people say Windows Server 2016 is more expensive, right? Because now you have to license per core. You might have heard of that. In the past, you just bought a Windows Server 2012 and you paid for 2 processors and that was that. Flat rate license. That's changed. Now Microsoft actually asks you to pay per core. And many people say, well, it's more expensive now. So what we've done here is we've taken, let's say, an older scenario with 10 dual circuit servers, 16 core, as you might have used 3 years ago. And this setup will be good enough for about 300 VMs. It's about 30 per server. So it's nothing, nothing fancy. And that'll cost you about 130,000 euros, list price. List price. That's not the price you would actually pay, don't get me wrong. So if you want real prices, please call your favorite representative and they'll give you real pricing. But here's the thing. With modern hardware that you can get today and modern processors, you can achieve the same performance and run the same amount of workload and the same number of virtual machines. And guess what? It's going to cost you the same thing. There is actually no real price difference from a purchase perspective. What is different is, yes, the cost per core has in fact. So that is actually true, but modern cores and modern servers are a lot more powerful than older servers and processors. And that'll give you the same performance, but in a much smaller footprint, much less hardware, but the same results. Now this setup here and these prices do not include any storage of any kind, because I don't know what storage you use. You might have a SAN system, you might have fiber channel, you might have NAS, I don't know. This is just servers and memory and processors and Windows licenses. So the storage isn't even included yet. Now another comparison, or another thing that people keep telling me is, yeah, because of the Windows 2016 licensing, I'm going to stay with Server 2012, and I'm going to add the storage functionality using VMware and vSAN. Does anyone here use VMware? Who uses VMware? Hands up. It's okay, don't worry. VMware, okay. Does anyone use vSAN already? Where to find? No. All right, but anyway, there's a lot of, and VMware will tell you that as well. So the question is vSphere and vSAN with 2012 R2 cheaper? Because there's no core licensing. And the answer is definitely not. If you want the same functionality as you would get with Windows Storage Spaces Direct, You'll have to get that 2012 license, which will cost you $4,800. You're going to have to get some vSphere, and you're going to need the Enterprise Plus edition. There is no other way past it. And that's another $7,000. You're going to need vSAN, which will set you back $10,500. And overall, you've paid 22,000 euros just for software. Now, if you did that with the 2016 server, the basic server is also $4,800. There is no price difference. Then you'll need to license the additional 24 cores to make that 40-core limit here, and you're done. So it's actually not more expensive or cheaper. In fact, the lowest cost option is just going with Server 2016. Now, what I'd like to show you now is what Fujitsu can offer. What kind of stacks do we have in terms of Windows Server and Server 2016 and Storage Spaces Direct. But before we do that, I would just like to show a little movie. And let's see if this starts automatically. No, it doesn't. Hang on. There we go. So one of the key things we would like to address is how you purchase, how you design, how you plan, how you build your solutions. And I guess in the past, most of us were kind of the do-it-yourselfers. It's what you did. In the IT industry, if you ran a data center, if you operated servers, well, that's what you did. You'd buy servers, you'd buy some software, you'd put it together, or you'd get help, right, from your favorite partner, and they would do it for you. In any case, it would give you a lot of flexibility, of course, because you could build whatever you liked, just using bits and pieces, like a Lego. You know, Lego's like the kids' toys. So you got all these building blocks, and you can build whatever you like. If you are creative enough, if you have the ideas, the visions, and the time, and then, of course, does it work? If you stay with standard setups and something that is very, very, a proven, standardized setup, then it'll work, probably very quickly. But that means it's not very flexible and future-oriented. You're going to have setups that are always the same. So how do you start doing new things, things you've never done before, things you've never tried, never tested? Then if you're doing it yourself, there's a certain risk attached. Now, at the other end of the spectrum, you get these ready-to-run things like appliances, right? So you buy an appliance, you plug it in, you switch it on, and it works. And that is, of course, brilliant because there's no setup time. There's no risk either. It just works. But there you've got that little, you gain speed, but you're not very flexible anymore. One of the appliance examples I like to use is a toaster, right? You might have one in your kitchen, so you put toast inside it. And there's no setup for a toaster. You just, you unbox it. When you get it from the store, you plug in the power and you put your bread in and you push down the lever and it works. But it doesn't cook your soup, or it doesn't fry your meat. It doesn't, it doesn't make jam. It only does toast. So appliances are very good for certain applications where you already know exactly what it's supposed to do, you know the outcome. And then it might be easier to use an appliance. So if you know you just need something that toasts toast, you get a toaster. You don't do your toast in the oven or in the stove, right? Or on a camping stove or whatever it is, what you use a toaster. Now, the PrimeFlexes are primarily designed for these use cases where we've got some ready-to-run appliances in the PrimeFlex family, but we've also got these so-called reference architectures. A reference architecture is like a cookbook recipe, and it basically says, if you have this number of users and this kind of application that you need to run, you'll need the following hardware. You'll need this servers or storage systems, you'll need these software licenses, this kind of networking, and it will basically give you a guideline of how to proceed. And it will help you to determine the basic starting point. It's like when maybe some of you like to cook at home, maybe as a hobby, and you want to cook something that you've never done before, so you go online on the internet or something, you get a recipe. So you look at the recipe and it says, for 4 people, get this, buy that, and then it gives you instructions on how to basically mix it up, the ingredients, and then prepare it. And you might not like everything you see. So you might say, I'm not sure if I like, what could be an example? I don't know, maybe you don't, maybe you're a vegetarian. So there's meat in the original recipe, and because you're a vegetarian, you just kind of throw out the meat, and you put in, I don't know, soy, or you put in fish instead, some seafood, and you can modify it. So reference architectures are kind of in between the just getting building blocks and ready-made appliances. They give you a basic starting point, but you can modify it, and it's flexible and adapt it to whatever kind of needs you have. Now, your favorite partner is going to help you to do that, of course, and get that reference architecture to start as a starting point and then modify it and optimize it for your specific needs. So PrimeFlex has been around for a while. This is a brand that we launched, I think, 3 or actually probably even 4 years ago. And in the meantime, we've got customers all over the planet and the world that have used PrimeFlex, and there's all kinds of benefits involved. And one of the important ones here is, for example, setting up clusters within literally less than an hour, so you can be productive by the end of the day. When your PrimeFlex gets shipped on premise, a lot of the preparation work will have been done by Fujitsu and your partner already by the time it gets to your site. So then it's kind of like literally just plugging it in and switching it on, and it works. And there is nothing much else you need to do. Now, that doesn't mean you can't. If you insist, we'll still sell you bits and pieces, and you can still set up your own environments by yourself if you insist. But if you'd rather get it done over with quickly, get a PrimeFlex. Here are a couple of customers that use PrimeFlex right now. I'm going to mention 1 or 2 of them, like Make IT and Desgagnés. I'm going to mention those a little bit later and give you some ideas of how they use these PrimeFlexes and why. I'm going to start with a small cluster. It's called the cluster in a box, and this is a solution designed for anything like 5 to 15 virtual machines. I'm going to say this is the lowest cost virtualization platform you can buy today. There is nothing in the market that will give you these results at a lower cost, but still give you the availability and the performance you expect from a cluster. Does anyone here actually run a cluster in their data center? Can I see some hands? Who has clusters? So you do. Is that VMware, or does some of you, is that VMware clustering? No? Hyper-V? Windows? Oh, good. All right. So a typical cluster would be like that, isn't it? You've got some servers, you get some storage networking. Could be Ethernet, it could be fiber channel, it doesn't really matter, but there's a storage network, and you get a storage box connected to that. You could do that, or just get one of these, and you're done. This is a hyper-converged product, and in fact, this one is pre-configured, pre-installed. It's an appliance. This is the device that is up and running in less than an hour. So but from the time it's shipped to your premises to the time it's actually online, we say less than 60 minutes. A lot of our engineers actually manage to do this in about 45 minutes. And then you're up and running. Now, this thing can scale small, okay? This is a cluster that will run 5 to 15 virtual machines at very, very low cost. I'm going to say you can probably get away with less than 20,000 euros all in. That's the software licenses built in, the hardware built in, and you're done. So it's very, very low cost, ideal for branch offices, remote locations, and places where there's no service and no support, or it will take a long time to get there. Also, if you have multiple locations, because then you need low cost, right? You can't afford to spend, say, 100,000 euros times 10 locations, or 5 locations, or even 3. So you need something that's low cost, reliable, and still highly available. Now, it's based on the Primergy CX product, and it runs plain vanilla Windows. There is no additional hardware or software in it. There's no virtual storage appliances. There's no additional third-party software that you need to license or maintain or manage. There's no additional hardware, any kind of controllers or firmware that needs to be updated and maintained. And everything that we don't put in means you don't need to pay for it. That's why this machine is so low cost. Everything we don't put in means there are less points of failure. There's fewer things that can break, fewer things that need to be maintained and upgraded, updated, fewer things that need to be maintained in your life cycle management, et cetera, et cetera. So it's a very, very straightforward, plain vanilla Windows. And in the cluster in a box, you can choose the bits and pieces according to your needs. You can choose low power or high power processors, a little bit or a lot of memory. You can choose any type of hard drives, from flash, which is very important. Remember, you're going to need the flash devices for the performance, but you can combine some flash with some, they're called nearline SAS, but they're SATA hard drives. So you combine the very low-cost SATA hard drives with some flash, you get excellent results every single time. And in fact, you can even get the cluster in a box with a standard edition of Windows. And the reason we can do that is the cluster in a box has a little twist inside it. It uses shared SAS storage. I'm getting a little technical. I hope I'm not, tell me if I'm getting too technical, okay? But so that shared SAS storage lets us even use a standard Windows server and still get all the benefits of storage spaces, such as that tiering, that rotation, the mirroring, the parity, drive fault tolerance, node fault tolerance, and all these fun things. So we can do that even with a standard edition of Windows if we so choose. And here's the other beauty, you do not have to have 10 gig Ethernet. The cluster in a box will even run in a 1 gigabit environment, and that means you don't need to upgrade your existing network or expand that or get 10 gig if you don't have it, which is especially important in branch offices and remote locations. That being said, it doesn't scale very large. Now, the cluster in a box will go to about 200 virtual machines maximum, but if you need to get bigger than that, then you use these. And this, then, would be our storage space direct reference architecture. There are, right now, we've got 2 nodes. We're calling one of them the performance node, and the other is the capacity node. Main difference between them, I guess if you look at the storage configuration, the performance node has NVMEs, actually even 4. It's got a whole bunch of SSDs inside and some regular hard drives. So I think you can kind of guess that the performance node is a beast when it comes to storage performance. And then the capacity node is kind of, well, it's got some flash, but it's only SSD and a whole bunch of very large hard disks inside. So this node here tends to be a lot lower cost per terabyte, but of course you're not going to get the exact same performance. Now, talking about performance, when we mean performance, that is stellar performance. I'm going to show you some figures in a minute. It is just ridiculous how fast storage spaces can get if you configure it properly. The reason I'm showing you this is very simple. Microsoft has a very specific and very stringent requirements for which hardware you may or may not use in a storage spaces cluster. You're not allowed to use any hard drives. They have to be specifically certified and supported. The same goes for the server, the SAS HBAs, the network adapters, and everything else. Microsoft has a very, very strict certification process for Storage Space Direct. If you try to do your own or build your own Storage Spaces Direct cluster, chances are high that you'll make a mistake. And the bad news is it might even work, but it cannot be supported. So I would really urge you to get help from your favorite service provider, help them to find your requirements, and they will then use the supported hardware list, the hardware compatibility list, to find the appropriate number and type of hard drives, same as, for example, which servers are supported and which ones are not. If anyone wants to know why the requirements are so strict, please ask me after the session, because I'd have to go deep into the technical bits and bytes, and I'm not sure if everyone's interested, but it's very, very strict. If you want to be on the safe side, use these reference architectures. But remember, you can still modify, for example, the memory amounts. You can choose how much memory goes in. You can choose the processor type as well. So you can scale from small to large. If for some reason you do need to build your own, for whatever reason, I don't recommend it, but if you need to, I would really, really urge you to take that Windows datasheet of ours, because this datasheet contains the list of supported and released hardware. But the hassle and the work you'll have with it is not worth it. And the risk of ending up with an unsupported configuration is also not worth it. You don't need to. We've done all of that for you, and your favorite provider and service provider will help you to get the configuration that works. Now let me show you some case studies of ours that have already used this or are already using it today. So one of our customers is using this for a remote branch office setup, as I kind of explained earlier. These are kind of two capacity nodes with very, very minimal configuration, like small processors. See, so there's nothing, very fancy in there, just a little bit of memory, a couple of hard drives, not even 3, there's just 2 in there. So you can, again, remember, you can change this within reason. There's 2 nodes, and the 10 gig Ethernet is just a direct connection between the two. There's no switches involved or anything else. And that keeps the cost very, very low. And this is a customer of ours who will deploy this 80 times in their remote and branch offices. So that's 80 times 2 servers. And the main reason was super low cost, and they wanted to get rid of VMware. VMware is just too expensive. And I said, no more VMware for us. That's not an option anymore. Another customer. Now, customer number 2, this is a slightly larger setup. This setup here is for about 50 to 100 virtual machines. And what's special about this is it actually uses that dual data center setup. So we've got a data center number 1, data center number 2. Each data center has 2 servers. It's kind of the picture I showed earlier. In this case, the 10 gig Ethernet was already in place between the 2 locations, because the customer had been using a VMware and NetApp Metro cluster setup in the past. So we didn't have to do much about the networking. It was already usable. But they also wanted to get rid of their NetApp storage and their VMware due to cost. It was up for a refresh, and refreshing that would have been ridiculous. So we were able to provide that at about 1/3 of the cost of refreshing their traditional VMware and NetApp setup. Here's some performance numbers from that actual setup. So this is a 4-node, 4 servers, 10 gig Ethernet. And this, what we can see here is the result of something called VM Fleet. VM Fleet is turning out to be Microsoft's primary virtualization benchmarking tool. It's a standard tool, and VM Fleet what it basically does is it spins up virtual machines with a dummy workload inside, and it does that until the server has reached its processing and memory limit. and then it starts up a disk workload just to see how much performance you can get out of the hard drives. So what we're getting here out of 4 nodes is 600,000 IOs in total. And this is a very realistic workload scenario where there's 2/3 reading and 1/3 writing. And the latency overall is not visible up here, but the average latency over all the nodes is just over 1.5 milliseconds. So it's not that bad. Now 600,000 IOs, to put that in perspective, is enough to run 1.5 million Outlook Exchange mailboxes. Just on perspective, 600,000 IOs is enough to run 10,000 virtual machines. So the storage, in fact, is so fast that no processor or memory in the world right now could even handle that. That's how fast storage spaces direct is. And there's no hardware storage involved. There's no RAID in that. There's no fiber channel, no nothing. It's just some servers and some Windows and a bunch of flash and mechanical hard drives. Now, another customer of ours has decided to scale really, really big. And what they're going to scale to is 1,000 or more VMs and 100 terabytes capacity. This is a disaggregated setup. It's not hyper-converged, and the reason I'm showing you this is for a very simple reason. This customer here decided to separate storage down here on these servers from the compute or Hyper-V cluster up there. Main reason being, their internal processes and procedures and their team setup was such that they had a storage team and they had operational procedures for buying, maintaining storage, and that was separate from the compute team. There were different people, different teams. In cases like that, hyper-converged doesn't work well. See, a setup like this, just to go back, where everything is in one single server, if your organization has fragmented responsibilities, where you've got some storage people, some compute people, some operating system people, this ruins everything. Just imagine for a minute you run out of space. You're out of disk storage. Whose problem is it? Is it the server people's problem? Is it a Windows problem? Is it the storage problem? What if a hard drive fails? Who in your organization has to get that trouble ticket and who has to resolve it? The storage team? The server team? It's not clear anymore because in a hyper-converged setup, there is no more clear separation of responsibilities, is there? Which might be the whole point. In many customers, that's exactly what they're trying to do, is to not have fragmented responsibilities. In any case, this customer said, no, I'm not going to change my organization. It's too complicated. But by the time I've changed my teams and my people and my processes, it's going to be like 10 years from now. So I would like to keep everything the way it is, but give me the new technology. And that's why they decided to separate. So there's a separate storage layer, and it does storage only. For the more technical in this room, this is called a scale-out file server. And you can do that on Storage Spaces Direct. Up there, you've got the Hyper-V layer, which is the hypervisor and application layer, and it's separated by, you could argue, a storage network. So it is traditional, after all, isn't it? And you can do that, and it works beautifully well. So why would you do all of this with Fujitsu and not with, say, someone else, like Dell, for example? Well, first, we've done this for a while. And I would like to point out that cluster in a box. The cluster in a box has been around for 5 years. This is a product that is now in its 3rd life cycle. It's been around for 5 years. And when we launched the cluster in a box, no one even knew what hyperconverged was. That word didn't exist. It was coined a lot later by, say, Nutanix and SimpliVity and VMware. They started using that term hyperconverged, but we've been doing that a lot earlier than them. Now, the cluster in a box is, these guys here, they use that, and Groupe Desgagnés is a Canadian shipping company, family-owned business. They have 19 ships, freight. It's freight only, not passengers. And they have 19 ships doing the North Atlantic routes, so transatlantic. And actually, in fact, I think 2 or 3 ships go all the way into the Mediterranean and to the end of the Mediterranean, all the way to Turkey and to the Black Sea even. And each of these ships has a cluster in a box on board because they need some on-board IT services, right? There's some PCs, there's an office on there. All the seamen have it's actually, I think it's a Panasonic Toughbook. It's one of these, waterproof, dustproof, drop-proof kind of tablet computers that they use when they go through their check rounds and just, do their validation of the ship, as it were, the inventorying and everything else. So they have the need for some limited, very, very, small, low-power applications on board, but it has to be reliable. 100%. If that ship's on the North Atlantic somewhere and something goes wrong, well, you can't fix it, right? It's not that simple. And on top of that, even when the ship comes into port, you can't just spend hours and days and fix the IT because that ship has to leave, has to depart. Ships at sea make money, ships at port don't. They cost money. So for Desgagnés, it was very, very clear that they need a box, a solution that can be installed on board while the ship is at port, being unloaded and loaded, and that's usually within less than 24 hours before the ship then goes back out to sea. So it has to be installed within that time. It has to be utterly reliable, has to be very low cost, and that's why they use the cluster in a box. Make IT, on the other hand, they use storage spaces direct. And Make IT, in fact, that's a Swedish hosting and service provider company. And Make IT, in fact, was one of the first clients in the world to use storage spaces direct in a production environment. And in fact, Make IT used storage spaces even before Microsoft had released it. Make IT deployed this already back in August, September last year. And that was 1 or 2 months before Microsoft even released the Server 2016 into public. And we helped them to do that because Make IT, being a Microsoft shop, mainly they told us, so are you going to help us make that work? Because if you're not, we're going to go and buy that stuff somewhere else. And then we said, well, it's not released yet. And Make IT said, we don't care. Make it work. So we called Microsoft, and Microsoft, of course, they were thrilled. They said, oh yeah, that's great, but it's not released yet. And we said, we know. The customer doesn't care. Long story short, Make IT's been using this productively, and they've been renting out IT services on their private cloud using storage spaces direct for over half a year now. And the main reasons also were lower cost. Low cost, low cost, low cost. Very simple. It's all Microsoft because that's what they do, and they love it for that. All right. Other reasons you'll want to do this. So it's not just our experience, but our servers are the best in the world, of course. One of the reasons why is they're the fastest. And this is an interesting benchmark. The virtualization benchmark here it's called the vMark benchmark. And that's kind of weird because it's a VMware benchmark. But, it doesn't really matter whether you run VMware or Hyper-V because the performance is just about identical. There's really no difference between the two. But that vMark benchmark's been around for years and years and years and years, and that's why we like to use it. So in the vMark benchmark, by the way, on VMware's website, not ours, this is a VMware benchmark. It's on their website. You can validate this if you choose. And what you'll find is in this category here, it says cores from 8 to 512. It's kind of like a performance class, right? So a small cluster with 8 cores up to 512 core cluster. And these bars here turn red every time a Primergy server is the best performing server in that class. When that bar turns gray, it's someone else's server. So it's not HP or Dell or Cisco, it's someone else's. Now, I don't know about you, but there's an awful lot of red in there. And in fact, it's about 3 out of 4 vMark benchmarks are owned by Fujitsu Primergy. And that simply means if you want to squeeze as many users or virtual machines onto a server as possible, you have to get a Fujitsu Primergy. You cannot use, say, a PowerEdge because it just can't handle it. Or the other way around, you'll need more PowerEdges to run the same workload than you would with Primergy. Energy efficiency. Now, I realize that in this part of the world, energy really isn't that much of an issue because it just kind of comes out of the earth, right? And it's there. So you might not really have an energy cost or availability issue. But then again, maybe it's not just about that. Maybe it's also about being able to keep your servers cool. And I know you might say, no, it's not a problem here. We just open the window, right? So we let some fresh air in and everything's cool, isn't it? All nice and true. However, a data center only has a limited amount of power that comes in, namely through power outlets. There's a socket on the wall, and it only has a certain number of watts, doesn't it? It's the same, the window only has a limited size. You cannot open more windows than are there. So as your demands scale, you need more servers and more power to run the workloads that you have. Well, just being able to use a Primergy will keep the demands for additional energy and cooling down. But that's not even the best part. As far as I'm concerned, the best story about this is that cool, safe, advanced thermal design, which will let you run these Primergies at up to 45 degrees with no higher failure rates. The failure rates are just the same as competitors' failure rates at 20 degrees. What that simply means is you can keep a Primergy and stick it anywhere you like. You can put it into a cabinet. You can run them in an empty toilet stall. You don't even need to open the window. You can keep the windows shut, and it will still operate and run and stay online. Which is one of the reasons why Gögnin, for example, chose the cluster-in-a-box on this as well. They don't have a rack on that ship. What they had is a little cabinet, and they put the cluster-in-a-box inside and just lock the door. That's it. Done. Reliability is another one of these. Why did Gögnin choose that? Well, there's the reliability issue. Now, this is a report that we didn't make. I know everyone in this room is going, yeah, of course. You know, how much money did you pay to get this report? And in fact, we didn't. And if you look closely at this report, this is a reliability statistic that says unplanned downtime of more than 4 hours. And lower percentage is better, right? So you don't want downtime. That means less downtime is good, much downtime is bad. Now you might argue, who paid for this? Well, there's the top 3 up there is IBM. So it kind of stands to reason that IBM paid for this report, which they did. And IBM, in fact, didn't release this. They never released this report. They kept it secret. But it was leaked, as things happen on the internet nowadays, so they get leaked. And we got our little fingers on it, and we discovered, hey, wait a minute, we're like the second best here after IBM. But being the second best after the people who paid for it, that's pretty good if you ask me. But that being said, you know, there's a couple of other vendors out there which have embarrassingly high failure rates that, you know, hard to justify that. And you could argue, even if these are fake numbers, you know, fake news, right? Everyone's talking about fake news. So yeah, even if it's fake, I'm going to do something. I'm going to double our failure rates from 2 to 4%, and I'm going to reduce these failure rates by half. So I'm going to skew the statistics in our competitors' favor by a factor of 4. Double our failures, halve theirs, and we're still better. To finish it off, I'd like to give you another little tip on how to save some money at the end of the day. Get OEM licenses. I'm not sure if you do that. The thing is, we know that a lot of customers like to get volume licenses, especially from Microsoft, which might seem attractive at first. But let me tell you, OEM licenses that you buy from the vendors are lower cost, and not just a little bit. As an example, a Windows Server data center license from Fujitsu will cost you list price 4,800 euros. List price. Your purchase price will be lower, right? The volume license will cost you 6,500. Now, that is a lot of saving right there. That's over 30% saved. And if you multiply that by the number of servers you have, multiply that by the CALs. Remember, you're going to need CALs as well. So if you get the client access licenses as OEM as well, which you can, you're also going to save 30 to 40% on your Microsoft licensing fees. And I'm going to be very clear with you, there are no downsides. There are a lot of people out there who say when you get OEM licenses, you lose this, you lose that, you can't do this, you can't do that. None of that is true. None of it. Ask your licensing experts, they'll confirm to you that you can do everything that you want with your OEM licenses in the same way you would with volume licensing. You can move your virtual machines around, you can, and in fact that's what we recommend, get an OEM license plus software assurance. And when you get your software assurance on top, guess what happens? It turns into a volume license. You get access to the volume licensing portal, you can get the keys you need, the media you need, and you get reassignment, right? If it's a volume license, one of the reasons people like volume licensing is that you can reassign your licenses to other hardware. That's okay. So get an OEM license at 30 to 40% lower cost, add the software assurance on top, which is still going to keep the cost much lower than a volume license, and it becomes a volume license. Even if you cancel the software assurance subscription immediately. So you pay the first 2 years, and even if you don't pay software assurance, it remains a volume license perpetually. Another bit of way to save some money. How does that sound? Yeah. So there's all kinds of ways we can help you to save money, invest that money in other things, which would be more services, more hardware, more licenses, more something else, and don't spend it or waste it on unnecessarily expensive licenses, whether from Microsoft or VMware or anything else. And finally, if you do like to build your own systems, Fujitsu has something called a system architect, which is a Windows application that will let you build and design entire data centers, not just a server, but entire racks, even multiple racks with all the cabling you would ever need. That could be SAN cabling, Ethernet, power cabling, and not just one rack. You could do that with 10 racks. You can simulate entire data centers, and the system architect is publicly available on the web. Just Bing it or Google it or whatever you do, and download it. And what you'll get is list prices. You'll get a list price database of euro prices in Germany. Those are the prices I've been quoting today, by the way. And these prices, of course, have no resemblance to what you will pay ultimately. But it's great for comparison purposes. You know, what if I did this? What if I tried that? What would the pricing do? So it's a great way to kind of simulate a couple of scenarios. And that takes me to the end, and we're done. I think more or less on time, aren't we? Is it 10 o'clock? All right. Now, this is actually a hard stop because we have more on the agenda today. But I'm going to be around for a while, and so will Jonas. If you have any questions, any kind, be it technical, licensing, cost, support, or anything of the kind, feel free, drop by, ask, and we'll be more than happy to help you out and give you the answers you need. And if we can't give you the answers now, we'll find them, and then I'm sure you'll get in touch with everyone, right? So thank you very much for your time. And